The concept of a limit in calculus is very important because pretty much everything we talk about in calculus is all derived and based on the limit. So it's really important to get a good understanding of what a limit is. So we're going to start off with the conceptual understanding, and then we're going to work up to more detailed formal definition. Start talking about the idea of a limit. What I want you to do is look at this first graph here, A, where the function is x squared minus 4 over x minus 2. Very broad explanation of a limit is if I asked you to look on the graph of f of x and I asked you to look to see how the function is behaving approximately at x equals 2. In this area, at x equals 2, here's 1, here's 2, what is happening in that area? That's a very broad statement to make about limits. So now, getting more detailed, if I were to look at this graph, if I were to trace it left to right, as x gets closer and closer to 2, what's the y getting closer and closer to? So as I move along this line, tracing it, I'm getting closer and closer to the y value of 4. Now, for a limit, the idea is what is happening to the value of a function as x approaches some number. You don't actually have to reach that value of the function. It's what am I getting closer to? The way that we would write this down, the notation would be the limit as x approaches 2 of f of x is equal to 4. As I get closer and closer to 2, as I come this way from this side, I'm getting closer and closer to the y value, or the value of the function, 4. In general, I would write down as x approaches some value a of a function, what is that getting closer to? L would be the limit, and a is the value of x that you're getting closer and closer to. So looking at this next graph, if I trace it coming from the left, I'm approaching a y value of -1. So this notation would look like this. The limit as x approaches 2, but I'm coming from the left-hand side, so where we normally would put an exponent, I'm going to put a little negative sign to state that I'm coming from the left-hand direction of the function g of x. That is -1. As I approach the x value 2 coming from the right, now I'm coming from this way, as I trace it, it's going to be 1. So these are called one-sided limits, where I'm looking at just coming from one side. This, where I don't have a direction indicated, that would be a two-sided limit. So you'd have to be coming in from both sides. Now, looking at this third graph, I would say the limit as x approaches 2 from the left of h of x. If I trace this, coming in from the left, there's a vertical asymptote here. So my y value is increasing without bound. I would say that the limit is infinity because it's increasing without bound. Now, if I say as the limit as x approaches 2 from the right of h of x, if I trace it coming from the right, again, this is increasing without bound. The value of the function isn't approaching a specific value. This is the intuitive definition of a limit. You're looking to see, as x approaches some value, what is the value of the function approaching? And that value of the function does not have to exist because the limit is what are we getting closer to? There's many, many ways to evaluate a limit. One way which we're going to start off with, is using a table of values. All right, so in this question, we're going to evaluate the limit as x approaches 0 of the function sine x over x. Since we want to get values that are getting closer and closer to 0, I'm going to start off with negative 0.1. Then I want to get closer to 0, so then I'm going to evaluate it at negative 0.01. And then I want to get closer, so I'm going to keep picking values that keep getting closer and closer to 0. Now, because I'm looking at the negative values that are getting closer and closer to 0, this would be coming from the left side. Then, coming from the right side, I want to pick values that are bigger than 0 coming from the right, but I want to get closer and closer to 0. So I'm going to pick the same numbers. I'm just going to do it on the positive side because I want to be coming in from the right. So now I can use my table function on the calculator, or I can just plug in by hand. I want to find my corresponding function values for each of the x values. When I plug in negative 0.1 into this function, I'm going to get 0.998334. Then I'm going to get 0.999983. Then I'm going to get 0.99999983. Then I'm going to get 0.999999. A lot of nines. So on this side, coming from the left side, it looks like it's getting closer and closer to 1 as x gets closer and closer to 0. Now when we do this for the right-hand side, if I start plugging in values, I'm going to get 0.998334. Then I'm going to get, when I plug in 0.01, I'm going to get 0.999983. And then it's going to keep going. So coming from the right-hand side, the value of my function is getting closer and closer to 1 as x is getting closer and closer to 0. So I can state that the limit as x approaches 0 of our function f of x is approaching 1. Now we can verify this by looking at the graph. If I trace the graph, coming from the left, my y values are getting closer and closer to 1, even though the value of the function doesn't exist at 0 because it's undefined. It's getting closer and closer to 1, even though it doesn't exist. And coming from the right, it's getting closer and closer to 1 as well as x approaches 0.